Hello friends, this is Jim with Science Talk. And before I get started on the story I wish to share with you, I want to remind everyone that to please share these videos, to please subscribe, hit the bell so that you know when I drop a video in. And also, I hope you will consider supporting the work I do here by becoming a patron at patreon.com/Science Talk with Jim Massa. If you are already a patron, I thank you, and I thank you for your continued support. I want to discuss with you polar ice. You might have heard some recent stories in the news about what's happening in Antarctica, and I will have a video on that shortly. Right now I want to talk about polar ice in both the northern and southern polar regions. Polar ice is melting quite fast in both the north and the south. In the high latitudes in both hemispheres, the polar ice is in retreat. Two studies support concerns for the ice caps in both north and the south. Now, of course, in the south, we're talking about the Antarctica ice sheets there. That is a landmass ice, whereas in the Arctic region, we're talking about the Arctic Ocean when the seawater itself freezes. Now, the point here is that in the Arctic Ocean, a lot of the seawater will freeze, and you will get layers, meters of ice and so forth. The overall volume does not change. So when the ice melts in the Arctic Ocean, the volume stays basically the same. If the ice is melting in Antarctica, which it is, that ice melt does add to the level of the oceans. It increases the sea level, causing it to rise. Now, the problem with the Arctic is that when the ice is, one, thinner, two, does not extend as far south as it typically does over the course of a autumn-winter cycle and so forth, and three, does not persist as long. Instead of incoming solar radiation reflecting off the ice, what we call albedo, back into space, we now have more open water. The water now absorbs the heat, making the ocean, warmer. And that warmer water will help, one, melt whatever ice is already there faster, two, minimize how much ice can form in the first place, because the water that is now warmer has to cool down that much further. So there are things that are happening. So let's discuss some of the findings here. A British team using satellite data has revealed that the retreat of what's called the grounding line of many Antarctic glaciers has accelerated to 5 times historic levels. Now, grounding line of Antarctic glaciers, what is meant by that? You have the ice sheets on the land, but the ice sheets also move off the land out into the ocean. The grounding line is where the ice is thick enough and is actually on the substrate. Even though there may be water, you pass basically the shoreline, it's on the substrate. It's grounded. It's in the ocean, but it's grounded. That tends to stabilize matters. I'll have a story in my next video that will discuss what is happening with that underwater ice. Basically, it's melting. Spoiler alert, but it's melting. So they're looking at, using the satellite data, they're looking at this grounded line of glaciers, and U.S. scientists have confirmed that in Arctic waters, now this is true for both in West Greenland and in Antarctica, The ice sheet is now melting faster than any time in the last 450 years. Both studies indicate sobering evidence for long-term consequences of climate change due to human activity. The Greenland Ice Cap holds enough water to raise global sea levels by 7 meters. It's 58 for Antarctica. Now, the West Antarctic ice sheet, just the West Antarctic ice sheet alone, holds enough water to raise sea levels by up to 5 meters. So the 58 meters I just mentioned was if all 2 miles, all the ice in Antarctica melts, and all that goes into the ocean. And we're talking about 2 miles thick of ice or so. The UK measure of Antarctic ice retreat is important because it confirms on a wider scale what individual measurements of glacier retreat have already demonstrated. That increasingly warm southern ocean waters are melting the ice at depth. Depth in this study is critical. Right? This goes back to the point I just made where I explained what the grounded glaciers are about, and this is where I'm getting at. Glaciers move slowly because, ice is just creeping along. But the ice tends to be grounded, or anchored, if you will, in the bedrock as they flow off the continent. And as they flow, basically from weight, what have you, the ice just plows, grinds up the ground, digs up a bunch of stuff, and so forth. So these glaciers move slowly, they flow off the continent, and they can be grounded again up to 1 kilometer deep off the continental shelf. Now the continental shelf is basically that part that just decreases with depth very gradually. So you have the shoreline, here's the water coming in here, and it just continued past. Like when you go to the beach and you walk out on the beach and you can swim out a little bit, you're basically over the continental shelf. At some point, the continental shelf will dramatically go down. And at that point, it becomes known as the continental slope. And it descends much more rapidly until you get down to the deep oceans. So we're talking about ice grinding itself down on the continental shelf, which of course is sort of like putting on the brakes, right? So it helps retard the movement of ice towards open seas. The further from the coast the grounding line, the slower the glaciers flow. And therefore the more stable the ice shelf, and the slower any consequential rise in sea level will be. Hans Conrad of the University of Leeds in the UK and colleagues report in the journal Nature Geoscience that they used the European Space Agency's satellite Cryosat-2 data to track the changes in the grounding line along 16,000 kilometers of southern polar coastline. So this is quite extensive. Around West Antarctica, more than 1/5 of the ice sheet has retreated faster than the 25 meters or so a year that has been normal since the end of the last ice age. In some cases, the retreat of the grounding line has been 5 times that rate. What does this mean, the retreat of the grounding line? It's basically moving closer. It's not as far off the coast as it has been. Right? Remember I just said that the further from the coast the grounding line is, the slower the glaciers flow, and the slower the melt, the slower any increase in sea level. Well, this grounding line is moving closer to being offshore. Therefore, this is helping speed things up. So this retreat has been extreme in 8 of the ice sheet's 65 biggest glaciers. So, this is a quote from Dr. Conrad. Our study provides clear evidence that retreat is happening across the ice sheet due to ocean melting at its base, and not just at the few spots that have been mapped before now. In other words, more extensive. He continues, this retreat has had a huge impact on inland glaciers because releasing them from the seabed removes friction, causing them to speed up and contribute to global sea level rise. Basically what's happening is that instead of grinding this up on the rock, you get this little bit of a melt underneath, and you in essence have liquid water at the base, and that serves as a lubricant to help the glacier move along better. Far to the north, ice is also melting. Eric Osterberg of Dartmouth College in New Hampshire and colleagues report in the journal Geophysical Research Letters that they collected 7 ice cores from a remote zone in the West Greenland ice sheet where meltwater trickles down into the deeper snow and then freezes again. This new ice in the compacted snow provides scientists with a record of melting over time. And basically what you do is you can look at the cores, you can look at isotopes. And then by looking at the isotopes, you can tell when the ice is formed. I will be doing a video upcoming soon where I talk about what's called fractionation, where we can use isotopic information to reconstruct past climates. Researchers have been watching the apparent acceleration of the summer melting of Greenland's ice for decades. They have monitored ever-fasting rates of glacier flow and tried to identify direct influences on the surface of the ice sheet that might accelerate overall melting. So we're seeing the same situation. The grounding line is moving close to the shore, so the flow out into the sea is increasing. The ice then melts and sea levels go up. Direct observation of the Northern Hemisphere's largest concentration of ice is only about 5 decades old. The Dartmouth cores provide a total of almost 5 centuries of summer melt patterns. That's basically an order of magnitude. The ice core record ends about 450 to 500 years ago, so the modern melt rates in these ice cores are the highest of the whole record that we can see. The advantage of the ice cores is that they show us just how unusual it is for Greenland to be melting this fast. That is a quote from Dr. Osterberg. He continues, we see that West Greenland melt really started accelerating about 20 years ago, quite recently. Our study shows that the rapid rise in the West Greenland melt is a combination of specific weather patterns and an additional long-term warming trend over the last century. I have spoken to people who have studied Antarctica. At the University of Alaska, we used to have the PICO, Polar Ice Coring Office, where we used to store all the ice cores, and from Antarctica, from Greenland, and so on. And basically, the scientists knew it was melting, the ice sheets in Greenland. They did not realize how fast they are melting. And it came as a complete surprise. They basically underestimated how rapidly it's melting. But, as I discussed in previous videos, when you add this layer of fresh water to the ocean's surface, diluting the salinity of the ocean water, it then has repercussions, ramifications for the formation of the North Atlantic deep water. And I discussed in a little bit of detail the scenario and what goes on with in all of that. I suggest, if you have not already seen that video, to please go check it out. So, stay tuned. I've got some more stories talking about this coming right up. Thank you for watching. And again, please share, please subscribe.